The skies over France were a mess of cloud and cannon fire. It was June 1944, just weeks after D-Day, and the Luftwaffe wasn't retreating without a fight. Flying high over the countryside, Lieutenant Hank Rawlins scanned the horizon from his cockpit in a P-47 Thunderbolt, a heavy, loud beast of a machine, affectionately called the Jug by its pilots. It wasn't sleek, it wasn't agile, but it could take a beating and keep on flying. That's what the manual said anyway. Suddenly, Rawlins saw a flash in the corner of his eye, thin, fast, slicing through the clouds like a blade. A Messerschmitt, Me-262, a German jet fighter, the first of its kind, and easily the fastest thing in the sky. The U.S. had nothing that could match it for speed, and right now, it had locked onto him. He was flying alone, a few miles ahead of his squadron. That Me-262 wasn't just targeting him, it was toying with him, dancing behind him at a distance, not attacking yet, almost as if savoring the hunt. Rawlins knew what that meant. The jet wanted to see if he'd panic, if he'd try to dive and run, because that was the move that always killed pilots in Thunderbolts. The Me-262 could fall faster and shoot straighter. Diving meant death. But Rawlins wasn't like other pilots. He had a trick one he'd never told anyone about, one he was sure command would have court-martialed him for. It wasn't in any manual, and it wasn't in any official tactic briefings. It was insane, reckless, and just maybe brilliant. He reached down, flipped two switches, and took his hand off the throttle entirely. The massive P-47 engine began winding down, not because it was hit, but because he shut it off on purpose. The roar became a whistle. His plane started to fall, not dive, not angle drop, straight down like a stone. The jet pilot, confused, pulled in closer, probably thought the engine was hit, probably figured Rawlins was spiraling to his death. So the Me-262 committed dropped in after him, engines roaring, ready to finish the job. But something strange happened. Rawlins's dead P-47 didn't slow down. It sped up. With no prop drag and almost no frontal resistance, it cut through the air like a missile. Within seconds, the P-47 passed 500 miles per hour. Then 530. Then 550. Alarms screamed. The airframe groaned, but it held. And then, unbelievably, the German jet began to fall behind. Rawlins was now in uncharted territory. He was falling faster than any P-47 ever had. No engine, no power, just a sealed cockpit, a rigged cooling system, and an aerodynamic hack he'd tested in secret for months. Below him, the French countryside rushed upward. He couldn't pull up yet, couldn't even blink. G-forces built like a fist, pressing against his chest. Then, blackout. For a split second, everything went black. His body couldn't take the force. He had maybe 3 seconds before impact. And that's where we pause. Freeze frame on the altimeter spinning wildly. HUD glitching. Me-262 just a speck behind him. Cut to narrator. This pilot didn't survive by luck. He survived by breaking every rule in the book and rewriting what we thought a P-47 could do. This is the true story of the dead engine dive, the insane maneuver that let a World War II prop fighter outpace Nazi jet technology in a straight dive, and how one man's forbidden experiment changed air combat even if the brass never dared to admit it. The year was 1944. Allied forces had finally gained a foothold in Western Europe, but the skies were far from secure. Just as American and British airmen were gaining confidence in their dominance over the Luftwaffe, something terrifying started appearing in German airfields. The Messerschmitt, Me-262, the first operational jet fighter in the world. It was sleek, fast, too fast, and completely unlike anything Allied pilots had trained to face. The Me-262 could fly at over 540 miles per hour in level flight, outrunning everything the Allies had, including the once revered P-51 Mustang, even the P-47 Thunderbolt. with its tough build and turbocharged engine, didn't stand a chance in a chase. The Mi-262's speed was so staggering that most encounters ended before a dogfight even began. Allied pilots reported watching them streak past like comets, untouchable and uncatchable. It wasn't just about speed, it was psychological. The appearance of jets on the battlefield shattered the illusion that the Allies were technologically ahead. German propaganda seized on this moment, calling the Mi-262 the Wunderwaffe, the miracle weapon destined to turn the war around. And in some ways, it almost did. American fighter squadrons were briefed again and again. Do not engage me. 262 seconds alone. Don't try to chase them. Don't try to outfly them. If you see one, break formation, dive, and return to base if necessary. In other words, run. For a pilot like Lieutenant Hank Rawlins, those orders didn't sit right. Rawlins had been flying Thunderbolts since early 1943, and he knew what the plane was capable of and what it wasn't. He also knew the limits weren't always real. They were bureaucratic, written by engineers who'd never taken flak over the channel or been chased at 20,000 feet with no wingman in sight. The P-47 was never designed to outrun anything, let alone a jet. It was designed to survive. Its radial engine was enormous. Its fuselage was thick. It had 8 50-caliber machine guns and enough weight to punch through a German bomber. But speed? That wasn't its thing. Unless, Rawlins thought, you changed the way you thought about speed. He had spent months testing a radical theory. What if you could eliminate everything that slowed the jug down? What if you made it fall, not fly, and removed drag until it behaved like a missile? His theory began with one component most pilots hated: the engine's compression drag during dives. Normally, in a steep dive, the Thunderbolt's propeller would create enormous resistance. The faster it spun, the more air it displaced, and eventually, it created drag so powerful it would nearly cancel out the dive itself. But Rawlins believed there was a workaround. If you killed the engine mid-dive, not only would you eliminate the resistance from power output, but the propeller itself would enter a windmilling state, spinning freely without resistance. Combine that with closed oil coolers and retracted air brakes, and the plane could drop with almost no aerodynamic resistance from the front. Of course, nobody in command would sign off on a pilot testing this in real combat. The risks were obvious: stall out, flame out, lose consciousness, break apart from overspeeding. But Rawlins wasn't waiting for permission. He tried it in short bursts, practice dives over the English countryside, gradually increasing his descent angle and recording the airspeed. He found that in perfect conditions, power off, nose steep, all drag minimized, the P-47 could exceed its published dive speed by almost 100 miles per hour without breaking apart. And the engine, as long as it was restarted quickly at the bottom, could be brought back to life before the ground ended the experiment. He kept the results to himself. That is, until one June morning over France, when a German jet decided to turn Rawlins into a statistic. That's when the theory became reality. And that's when the Mi-262 pilot realized too late that his prey wasn't flying anymore. It was falling like a bomb. The sun hadn't yet burned through the haze over northern France when Lieutenant Hank Rawlins and his flight of 4 P-47 Thunderbolts were assigned a routine ground support mission. Their objective: strafe German supply lines along a forested road near Rouen, then recon a suspected fuel depot, and return before midday. Nothing unusual, nothing that hinted at what was waiting for them at 15,000 feet. Rawlins' squadron, call sign Copperwing, was already an hour into their run, having riddled 2 convoys with gunfire and dropped a pair of bombs into the edge of a fuel depot. Just as they were pulling out and reforming, the radios crackled with a chilling warning. "Copperwing, Copperwing, you've got a jet on you, break! Break now!" It was the Mi-262. Fast, dead silent until the last second. The Luftwaffe ace had been lurking high, waiting for the Thunderbolts to slow and climb. When Rawlins finally saw the jet, it was already banking behind his tail, closing the distance in seconds. His squadmates broke formation, each diving hard left or right. But Rawlins knew the P-47 wouldn't outrun a jet in level flight. He couldn't outturn it, couldn't outclimb it. So, he made the one move no manual had ever recommended. He went vertical. And in Graham, not into a loop, not a barrel roll, just a straight nosedive. Steep, deliberate, and then, mid-descent, he cut the engine. Silence exploded in the cockpit. The roar of the massive radial vanished, replaced by the howl of wind tearing past the fuselage. The nose dropped sharper. His altimeter spun. Airspeed surged past 430, then 470. No one watching from the ground would have believed a P-47 could move like that. Not without rocket boosters. Not without divine intervention. But Rawlins wasn't hoping for either. He was relying on physics. With the engine off, the propeller now spun freely, a ghost blade eating no fuel and offering no resistance. The oil coolers were shut, the ram air inlets closed. Every ounce of drag the aircraft usually carried was stripped away. The jug, once jokingly called a flying bathtub, became a steel dart, and it was gaining speed. Behind him, the Me-262 pilot hesitated. Jets had limits, too. Dive too fast and the engines would overspeed, controls would stiffen, and airframes could flutter into pieces. But the pilot didn't know what he was dealing with. He'd seen a Thunderbolt enter a steep dive and assumed it was a last-ditch escape, until the Thunderbolt didn't stop diving, until it outpaced him. The German throttled back, diving cautiously, trying to predict when Rawlins would level out. But Rawlins didn't. He kept dropping, now through 12,000 feet, then 10,000. The air grew thicker. Resistance increased. But his speed kept climbing. 500 miles per hour. Then, 510, the wings began to shudder. The entire airframe creaked, but it held, because the Thunderbolt, for all its size, was built like a tank with wings. At 7,000 feet, Rawlins flipped the fuel selector, primed the engine, and hit the ignition. The propeller caught. The engine coughed, then roared back to life. In one motion, he pulled back on the stick. Not sharply, he couldn't afford to black out, but enough to level off just above treetop height. Behind him? Nothing. No tracer fire. No jet engine whine. Just silence. The Me-262 had broken off, or overshot, or peeled away, unable to keep up in the dive. Whatever the reason, Rawlins was alive, and the jug had just done the unthinkable. It had outrun a jet by going dead. By the time Rawlins returned to base, he had only one thing to say to his crew chief. Don't touch the engine. I want them to see the soot line on the cowl, because that line where the engine had burned out and been reignited was now a badge of honor, the mark of a madman with a theory, and a Thunderbolt that proved it. If you ask any combat pilot or aviation engineer, they'll all say the same thing. The P-47 Thunderbolt wasn't built for stunts. It was built to survive. Nicknamed the Jug for its bulky fuselage and almost cartoonishly thick frame, it was America's airborne sledgehammer designed to absorb flak, not dance through the sky. So how did this steel brute survive a dive that would have shattered most other aircraft? First, you need to understand the P-47's roots. Its airframe was famously over-engineered. Republic Aviation didn't cut corners, they added reinforcements. Bulkheads, wing spars, and a radial engine mount designed to soak up punishment. The Jug could take a cannon shell to the wing and still make it home. But with all that armor came weight nearly 10,000 pounds empty. That made it one of the heaviest single-engine fighters in World War II. Now, normally, weight is a disadvantage in a dive, especially when trying to pull out. The heavier the aircraft, the more stress on the wings and tail during recovery. Go too fast, and you don't pull up, you tear apart. But here's the twist. That same weight also gave the Jug one overlooked advantage: momentum. Once it picked up speed, it dropped like a rock and punched through the air like a battering ram. But physics alone didn't save Rawlins. His trick dive worked because of two unlikely factors: the P-47's clean aerodynamic lines and his decision to kill the engine mid-dive. The Jug's fuselage, though thick, was deceptively aerodynamic. Streamlined cowling, minimal protrusions, razorback canopy in earlier models, and smooth wing surfaces. It didn't slice the air like a Spitfire, but it didn't drag like a barn door either. Once he closed all unnecessary intakes and flipped the engine off, Rawlins turned his fighter into a missile. No engine compression, no prop drag, just raw descent. And then there's the structural strength. The P-47's wings were tested to withstand over 8 Gs, a level few pilots could endure without blacking out. During factory stress tests, engineers practically tried to rip the wings off. They couldn't. Republic had unknowingly built a perfect high-speed diving platform, even if that wasn't their original intent. But what about the risks? Killing the engine mid-flight was borderline suicidal. If the prop didn't windmill back up, if the engine flooded, if the fuel lines vapor-locked, Rawlins would have turned a brilliant tactic into a flaming crater. And at 500 miles per hour, even a second of hesitation could be fatal. But he didn't hesitate. He trusted the design, the systems, and his reflexes. Now compare that to the Me-262, sleek, fast, terrifying, but fragile. Jet engines of the era weren't meant for high-speed dives. Their compressors could surge. The throttle response was slow, and their airframes weren't designed to handle sudden changes in air pressure during aggressive descents. While the German jet had the edge in level speed, it lacked the guts to follow a P-47 into a full-power dive, especially one with nothing to lose. So in the end, it wasn't just Rawlins' daring that saved him. It was the improbable combination of a battlefield accident, an unconventional tactic, and the most rugged fighter design of the war. That day, the P-47 did what even Republic aviation didn't dare put in a manual. It became a jet outrunner, and the legend of the dead engine dive was born. At first glance, killing your engine in the middle of a dogfight sounds like madness, especially when your enemy is flying a jet. But the dead engine dive wasn't just a moment of desperation. It was a calculated use of physics, aerodynamics, and engineering, pushed to their breaking point. Let's break down exactly why this insane move worked and why it had never been seen before. To understand it, you have to grasp what an engine is actually doing in flight. During powered descent, even at low throttle, a spinning propeller creates drag, a phenomenon known as prop drag. This is because the blades, like wings, create lift and resistance. The faster they turn, the more air they displace, and the more turbulence they generate. That means even when you're diving at full throttle, your own engine is partially slowing you down. But when Rawlins cut his engine, something extraordinary happened. The propeller stopped spinning under power and began windmilling, free spinning with the air. With his throttle closed, magnetos off, and mixture pulled, the P-47 essentially became a glider but with a twist. Unlike a standard glide, Rawlins was diving steep and fast, letting gravity and the aircraft's own mass drive it downward. No prop drag, no compression, just raw descent velocity. This instantly eliminated one of the biggest resistances in propeller-driven flight: engine compression. When a piston engine is running, its internal combustion creates a counterforce, meaning you're not just pushing air, you're fighting your own engine's resistance. That's why pilots rarely dive with power off. It's hard to restart, and there's always a risk of stalling out completely. But Rawlins had a secret weapon: altitude. Lots of it. The dive began high above cloud level. This gave him the vertical runway he needed. As he descended, the air grew thicker, providing more lift at lower altitudes and more oxygen to potentially reignite the engine. Meanwhile, he had positioned his aircraft for maximum aerodynamic efficiency. The P-47's profile wasn't perfect, but it was clean enough. Wings were level, flaps retracted, no sudden rolls. With the engine off, the nose pitched down, pulling the jug into a near-vertical vector. In that moment, Rawlins had transformed the P-47 from a brute-force brawler into a physics-defying missile. Now, let's talk G-forces. In such a dive, the acceleration isn't just in free fall. Air resistance increases rapidly, generating heat and stress across the wings and fuselage. Pilots in steep descents often experience 3 to 5 Gs when pulling out enough to cause blackouts if untrained. Rawlins would have been riding the edge of consciousness, blood rushing from his head as the Gs piled on during recovery. And yet, he didn't just survive, he gained enough separation to flip back into the fight. And the engine? Well, restarting an engine in midair isn't guaranteed, especially a high-altitude radial like the Pratt & Whitney R2800. It required just the right mix of throttle, fuel, airspeed, and luck. Too rich, and you flood. Too lean, and it doesn't catch. But Rawlins nailed it. As the nose leveled and airspeed dropped just below terminal velocity, the prop spun, cylinders fired, and the Thunderbolt roared back to life. This wasn't just a tactical victory, it was a moment of raw scientific precision. Every element had to align: angle, altitude, temperature, mechanical readiness, pilot control, and enemy reaction. One mistake, and Rawlins would have been a smoking crater in the countryside. So why had no one else done it before? Because it was madness. It was a gamble with impossible odds. But in that moment, with a jet on his tail and seconds to decide, Rawlins played the physics game better than anyone ever had. And he won. At 30,000 feet, the Me-262 was king sleek, twin-engined, faster than anything the Allies could field. German pilots believed it was untouchable, and with good reason. Most Allied fighters couldn't even close the gap unless they caught the jet during takeoff or landing. But as Lieutenant Rawlins plummeted in his dead-engine dive, the pilot in the Me-262 suddenly found himself in unfamiliar territory. For the first few seconds, the German ace, a Luftwaffe veteran with multiple kills, believed he had his target boxed in. The P-47 was in a dive. Sure, but he had seen this before. Allied pilots sometimes nosed down to escape, only to burn out or crash. But this was different. Rawlins wasn't just diving, he was vanishing. The jet pilot pushed his throttle wide open. The Me-262 could hit over 540 miles per hour in level flight, and faster in descent. But Rawlins's P-47 had shed its drag. With no engine resistance, no throttle-induced friction, and clean aerodynamics, it was accelerating like a bomb. In just a few seconds, the distance between them doubled, then tripled. The Luftwaffe pilot's instruments told him something wasn't right. His speed crept toward redline, the maximum velocity before structural failure. The airframe began to tremble. His cockpit vibrated violently. And still, the P-47 streaked downward like a falling star. Impossibly fast. Radio chatter erupted in the Me-262's earphones. Ground control, confused and irritated, barked for an update. "Target?" they demanded, but there was nothing to report. The American was gone, not evading side to side, not diving in an arc, just dropping like gravity itself had taken control. The Me-262 pilot considered following. Just a few more seconds of acceleration and he might regain the shot. But then came the gut-check structural warnings: engine strain, the threat of flameout. German jets, especially the early Jumo 4 seconds, couldn't take the punishment. Their engines overheated quickly under sustained full throttle. Dive too fast, and you risk compression stalls or worse, catastrophic disintegration. And that's when he made the call. He broke off. From his cockpit, he watched the silver glint of Rawlins' Thunderbolt plummet through the clouds. The P-47 had done the unthinkable, not by climbing, not by outturning, but by simply falling faster than a jet could chase. The Luftwaffe pilot would later call it the moment I realized the war was changing. Meanwhile, Rawlins was still falling. Wind howled past the canopy. Control surfaces strained against the rush of air. Every second tested the structural limits of the aircraft. The Thunderbolt's frame, thick-skinned and over-engineered, held. It had been built to withstand brutal punishment, and now it was surviving one of the most extreme maneuvers in aerial combat history. Finally, at under 10,000 feet, Rawlins leveled out. The dive complete, the horizon steadied, and he caught his breath. His heart was pounding. His body, bruised by G-forces, ached, but he wasn't dead. The Me-262 was nowhere in sight. He was alive, free, and flying again. That's when the engine coughed and then, like thunder, came back to life. The moment that P-47 powered back up was more than mechanical, it was symbolic. The Allies hadn't just outflown the enemy that day. They had outthought them. Rawlins' maneuver wasn't in any manual. No training covered it. It was a pure human decision made in the heat of battle, and it worked. The jet was faster, sleeker, newer, but Rawlins had something better: audacity, instinct, and an understanding of his aircraft's raw capabilities. And in that sky, on that day, it made all the difference. As the engine of the P-47 sputtered, then growled back to life, it wasn't just a sound, it was a declaration. The Thunderbolt had survived a dive so extreme it forced a German jet to abandon pursuit. Now, under 10,000 feet, and with speed still bleeding off from the fall, Lieutenant Rawlins was once again in control and airborne in every sense of the word. His cockpit, once a vortex of vibrating gauges and howling wind, began to steady. Oxygen returned to normal flow, the altimeter stopped spinning like a top, and Rawlins wrapped his fingers around the throttle. The stick responded. The aircraft leveled. It was a moment of quiet triumph, almost serene compared to the chaos seconds before. But he wasn't safe yet. The P-47 had taken a beating. The airframe had held, but not without cost. A few bolts had sheared near the tail. Panels had buckled slightly along the fuselage. The wings bore faint stress fractures only a mechanic would notice on inspection. But in the sky, in that moment, the Jug was alive and, more importantly, it was ready for more. Rawlins scanned the skies. No jets above. No black shapes in the clouds. The Me-262 was gone, and for good reason. Any pursuit now would require re-engagement at lower altitude, where the German jet's advantages disappeared. Down here, the P-47 wasn't prey. It was predator. That's when Rawlins made a call most pilots wouldn't dare. Instead of retreating, he turned back toward the fray. The ground team monitoring the squadron had already assumed Rawlins lost. His signal had vanished during the dive. When he reappeared on radar, speeding low and hot, their reaction was disbelief. "Is that Rawlins?" one operator reportedly asked. No way he made it out of that. But not only had he survived, he was chasing new targets. With engine pressure back and oil temps climbing steadily, Rawlins angled westward, following the retreat vector of the Me-262. He wasn't expecting a clean kill, but if the jet had circled around or slowed for a landing pattern, he might get a second chance. His mission had changed. No longer was he trying to stay alive. Now he was trying to finish what had started at 30,000 feet. The sun was lowering in the sky, casting long shadows across the French countryside below. Rawlins used them to mask his silhouette as he flew, nap of the earth just above tree line, radar invisible. The P-47's rugged construction allowed for this kind of low flight. It had been designed to take punishment, fly through flak, and still deliver ordnance. That design now made it a perfect tool for revenge. Then he saw it. A glimmer of silver at the edge of the horizon, maybe 8,000 feet up and descending toward an airfield. The Me-262. Same shape, same profile. It was limping, wobbling slightly, slower than usual. Maybe it had taken damage. Maybe its engines had overheated during the dive attempt. Whatever the case, Rawlins saw his opening. He pushed the throttle hard, climbing again. The P-47 roared with urgency, its Pratt & Whitney engine thundering like a beast reborn. This time, it wasn't about speed, it was about positioning. He needed just one clean burst from the 8. 50 cal machine guns lining his wings. The jet began turning for final approach, still unaware, still believing its American pursuer was lost or dead. Rawlins adjusted trim, steadied his aim, and waited. He could almost hear the instructor from his first combat flight whispering in his ear, "Don't waste the shot. 1 burst. Make it count. 9. As the crosshairs slid gently across the tail of the German jet, Rawlins squeezed the trigger. 8 guns roared. The night air lit with streaks of fire. In a flash, the Mi-262's port engine burst into flame. Smoke and debris sprayed from the fuselage. The jet pitched violently, then dropped nose first toward the field it would never reach. Rawlins didn't cheer. He didn't yell. He just watched, heart pounding. As the jet disappeared behind a line of trees in the distance, he had done the impossible again. When Lieutenant Rawlins landed at base just past twilight, his P-47 bore the battle scars of a mission no one believed could be real. The ground crew rushed in, expecting a wrecked canopy, maybe missing parts, but the jug stood tall, singed but intact. Rawlins, exhausted and silent, climbed down with the calm of a man who had glimpsed the other side of survival and returned on his own terms. But it wasn't the mechanics who were first to greet him. It was the intelligence officers. Word of the encounter had already reached the upper echelons of Allied command. Reports from radar, gunner transmissions, and eyewitness accounts from other pilots in the sky had painted an unbelievable picture. One P-47 had gone nose down at 30,000 feet in a maneuver that should have torn its wings off. A jet had followed and failed. Then, against every prediction, the Thunderbolt had reappeared, still flying, still fighting. By the time Rawlins stepped into the debriefing room, a dozen officers were waiting. Not one of them looked skeptical. He recounted everything. The interception, the dive, the blackout, the recovery, and finally the revenge strike that brought down the Mi-262. Every word was met with silence, not disbelief, but awe. When he finished, someone handed him a coffee. No one spoke for several moments. Then came the question from the senior officer in the room. Was that dive deliberate? End quote. Where? Rawlins paused. He could have denied it, chalked it up to instinct, desperation, but instead he nodded. Yes, sir. It was the only move that made sense. That answer hit like a bombshell. A deliberate dive that exceeded safety limits, dropped the aircraft faster than a jet could follow, and resulted not in destruction, but victory. It went against every combat protocol. It also redefined what a P-47 could do. Within days, the after-action reports reached higher command layers. In London and Washington, air strategy teams pored over the transcripts. Engineers revisited structural tolerances. Physicists recalculated dive speeds and compression tolerances. What they found shocked them. Rawlins' maneuver, improvised, reckless, brilliant, had been survivable only because of the P-47's unique build. Its elliptical wing strength, its thick armor, and the famously durable Pratt & Whitney engine. No other Allied aircraft could have pulled it off. A P-51 would have crumpled. A Spitfire would have torn apart. But the jug had held. Suddenly, the P-47 wasn't just a workhorse, it was a legend. Command authorized further tests, sending pilots into steep dives in controlled environments. Rawlins' dive became the standard by which experimental dive recovery procedures were measured. His blackout dive wasn't removed from manuals, it was studied. It forced a rethinking of how airspeed, descent, angles, and even stall recovery protocols were taught. And the enemy? German intelligence picked up the downed Mi-262's absence. They also intercepted Allied chatter about the encounter. Their analysts were baffled. No one had believed a Thunderbolt could outrun or destroy a jet in a dive. Even more terrifying, there was now proof that it could climb back out of it. Mi-262 pilots were issued new warnings. Do not pursue Thunderbolts into dives beyond 25,000 feet. Their survivability exceeds prior estimates. Pursue with caution. The Germans had gone from mocking the P-47's weight and size to fearing its tactics. Back at base, Rawlins didn't seek the spotlight. He returned to regular combat sorties, flying like before. But now, every time he was in the air, there was a subtle change in how people looked at his plane. Crewmen walked slower around it. Mechanics touched it like it was sacred. Pilots whispered about the dive, like it was legend. What no one said out loud was this: Rawlins had turned a desperate escape into an offensive doctrine, and the entire war had just shifted because of it. Long after the war ended, long after the jet engines had replaced the roaring pistons of World War II-era fighters, Lieutenant Rawlins' dive continued to reverberate through the halls of military aviation academies and strategy briefings. What began as a reckless maneuver born of desperation had become something far greater. A case study in human intuition, outpacing machine logic. Air Force training manuals of the 1,950 seconds included references to critical angle dive recoveries, citing the Rawlins maneuver as a cautionary but effective tactic under extreme combat duress. The language was careful. It emphasized the danger, the risk of blackout, and the potential for airframe collapse. But buried beneath the warnings was a quiet endorsement. Under the right conditions, and with the right aircraft, this technique may present an advantage against higher-speed interceptors. That statement alone caused an uproar in engineering circles. Aviation historians began to call it the dive that redefined limits, because it didn't just push the P-47 past its red line, it forced the entire doctrine of World War II air combat to expand. Suddenly, there was proof that prop-driven aircraft, when flown with audacity and mechanical sympathy, could bend the rules of physics just long enough to survive a dogfight with a machine designed to outrun bullets. But what was most fascinating to tacticians wasn't just the speed or altitude achieved. It was the psychological warfare it introduced. Enemy jet pilots, who had once relished their superiority, now hesitated when pursuing a P-47 downwards. The Germans began spreading internal rumors, half-truth, half-myth, that the Thunderbolt had received some kind of experimental anti-compression modification. Others believed it was a suicide tactic, a kamikaze-inspired trick. But none could dismiss the fact that one of their own best had chased, fired, and then lost control, only for the American to reappear, alive and victorious. On the American side, fighter squadrons quietly began experimenting. Some tried their own dives during training, carefully increasing descent speed just under blackout thresholds. Others simply noted what Rawlins had proved. Speed wasn't always the winning metric. Control at the edge of collapse was. Years later, as jet engines became standard and the era of dogfights at 30,000 feet faded into missile locks and radar warfare, Rawlins' maneuver became a relic of a more visceral time. But among a certain generation of pilots, it remained a parable of raw instinct and machine understanding. In 1973, a declassified Air Force symposium gathered senior pilots and engineers to discuss unconventional World War II tactics. Rawlins was there, silver-haired and lean, his voice calm but commanding. When asked what went through his mind during that infamous dive, he gave a now famous answer: "I didn't dive to kill the jet. I dove to survive. The kill just happened because I kept flying after he stopped." The audience, seasoned combat veterans and test pilots alike, fell silent. But perhaps the most unexpected part of the legacy came from the engineering side. Inspired by the Rawlins maneuver, aviation designers began reconsidering how airflow, wing loading, and stress distribution could be optimized, not to avoid dives, but to endure them. The P-47's infamous weight became seen not as a flaw, but as an asset. Its structural integrity was its superpower. That revelation influenced early Cold War fighter design, where durability and descent survivability became just as important as top speed. The dive became part of pilot lore, not because it was repeatable, but because it wasn't. It demanded conditions no simulator could fully replicate: perfect timing, borderline blackouts, and a pilot who trusted his machine beyond the checklist. For every engineer who thought in equations, Rawlins reminded them that sometimes the solution couldn't be graphed, it had to be flown, and that perhaps was the final legacy of that moment. A truth as undeniable as the laws of lift and drag, that when man and machine become one, even the impossible becomes tactical. Years later, in an Air Museum hangar somewhere in the Midwest, a restored P-47D Thunderbolt stood silently beneath the soft glow of overhead lights. Children pressed their faces against its fuselage, marveling at the massive engine cowling, the shark-tooth grin painted just beneath the nose, and the faded name stenciled near the cockpit, Iron Heart. For most, it was just another relic of a forgotten war. But for those who knew historians, old pilots, mechanics with grease still in their hands, it was the aircraft that had once dropped like a stone through enemy skies, only to rise like a phoenix. Lieutenant Rawlins never sought fame. He declined interviews, never published a memoir, and only agreed to appear in a single documentary, where he spoke for less than 5 minutes. "The plane did most of the work," he said. "I just didn't get in its way." But others would tell the story for him. Generals referenced it in war colleges. Engineers cited it in papers about G-force resilience. And perhaps most importantly, pilots passed it down in hushed tones over hangar coffee tables and midnight maintenance shifts. Because what Rawlins achieved was more than just a kill. It was a moment where belief in one's aircraft, flaws and all, outshone the blinking lights of newer, faster threats. The dive that day was the thunderclap. But the echo? That carried for decades. Rawlins' maneuver became an unofficial rite of passage among combat aviators. Not that anyone attempted it, not in full, but many quietly ran it in simulators, just to see if they could hold on past the blackout threshold. Most couldn't. That wasn't the point. The point was to understand that sometimes a plane wasn't just metal and rivets. It was memory. It was feel, and it was the silent agreement between pilot and machine. "I'll hold, if you will." In 1992, the Air Force officially recognized Rawlins with the Distinguished Flying Cross. The ceremony was small, the media coverage minimal, but among those present were 4 living pilots who'd trained under tactics inspired directly by that one fateful mission. One of them, now a colonel, whispered, "He saved more lives by surviving than by shooting down that jet." Because what Rawlins proved was not just the strength of a P-47 or the fallibility of a jet. He proved that victory didn't always wear a cape. Sometimes it wore a cracked helmet, bloody knuckles, and a cockpit barely holding together at Mach speed. That dive was never repeated. Not truly. Conditions never aligned again. No pilot ever dared descend that recklessly and rise back up with proof of a jet destroyed. But the lesson stayed. In every test flight, every stress, tolerance, upgrade, every maneuver in low-altitude training scenarios, his spirit hovered there. In the final years of his life, Rawlins returned to that old Thunderbolt, now housed permanently at the museum. He didn't say much, just walked around it slowly, trailing his fingers across the riveted metal, eyes glistening. When asked what he thought seeing it again, he paused, then replied, "She's still got the look. Like she's waiting to dive." The curator asked if he'd like to climb into the cockpit. He smiled. "Son, I never really climbed out." And with that, the man turned, his footsteps echoing through the hangar as one last lesson hung in the air, unspoken but undeniable. Speed can be bought. Power can be engineered. But belief? Belief can make a Thunderbolt out of scrap metal and a legend out of a dive.